This talk is going to be about Molecule, which is, about building state holders in Compose with Molecule. I'm Jack. You all probably can see me because I'm standing right here, so I don't know why I put a picture of me on the slide. That's why I decided to make the same slide with my cat, Chico. He's much cuter than me. I'm a senior Android developer at Trainline. I've been doing Android development for nearly 5 years now, and I've been working at Trainline selling train tickets for 2.5 years. At work, I'm really passionate about building scalable app architectures, especially ones that work well in big teams. So at Trainline, we have 35 Android developers, and this brings a lot of interesting challenges, let's say, all working on one repo, on one app. And outside of work, I like space exploration. I don't say SpaceX anymore, because that's a bit like a loaded term these days politically. Chess and Man City and the UFC. What am I going to talk about? Well, Molecule. So, what is Molecule? That's probably the first question to answer. Then we're going to have a very brief intro into writing some Molecule code. Then we'll try to figure out how does this actually fit into our app architecture and what problems is it really solving for us. Disclaimer, probably most of you assume senior Android developer at Trainline, talking about Molecule. Of course we use Molecule at Trainline, right? Well, no, we don't. We don't use Molecule in production at Trainline. All of my experience using this framework is from personal projects and just experimenting, playing around. But if you want a seal of approval that it is used somewhere in production, well, here's 2 apps that hopefully you're at least somewhat familiar with that definitely do use it in production. The first one is Cash App, and the second is Slack. So what is this whole Molecule thing we are talking about? Has anyone heard of Molecule before? A quick raise of hands, okay. Has anyone used Molecule before? Okay, John has used it. Well, it's actually kind of a hard thing to define, right? When I made that slide, what is Molecule? I was how do you explain this in plain English without showing some code? So I watched a podcast with a guy hopefully you've heard of who helped to write this library called Jake Warden. He described this as Molecule allows you to use the compiler magic of Compose for the pure manipulation of data. That's a very library writer definition of what something does, right? So in a more sensible way, it's Molecule is a simple but powerful library allowing you to create stateflow streams using Compose. And the really important part here is we're talking about Compose runtime, not Compose UI. A very common misconception a lot of Android developers will make is that you hear Compose and you think UI. We're not talking about using a UI framework today. This is a Compose talk, but it's not about UI. It's about using the Compose runtime. Compose is actually just a compiler plugin that is a way of reformatting your code to, when it's marked with the composable annotation, represent a state as a tree of nodes in memory. And Compose UI uses this to transform this state that's in memory into the UI that you see on the screen. But you can use it for a lot of other things. And Molecule is probably the best example out there that I've seen of using Compose for a non-UI purpose. So, enough kind of talking around the subject. I'm going to show you some code. So imagine you wanted to create a counter, right? It's a very simple stateflow. It has the type of int. You just want it to count every second, 1, 2, 3, 4. Well, you can do this with flows pretty easily, right? You just write a flow builder. You have a while loop. Every 1 second, you emit a new value. And you increase the count. It works pretty simply. You can transform this into a stateflow using the stateIn operator. But even initially, right, this code, if you're very familiar with flows, it's probably easy to read, but it's not super readable, right? We can do the same thing with Compose. We can create a mutable state with an int. We can do a launched effect and have the same while loop and then return the count. This composable, as you can see, the important part is it returns a value. It has a return type. And because of recomposition, every time the count changes, we just recompose the composable, and we reevaluate this and return a new count, and we get the exact same result. This is where Molecule comes in. Don't worry too much about the presenter part of this. I think sometimes people get scared by the whole presenter concept that comes up in Molecule. This is not MVP. It's just like a representation of some presentation logic. But we can transform this counter into a state flow by just calling the launch molecule method. And yeah, that's pretty much all we need to do. Every time this counter composable recomposes, we're going to get a new value in our state flow. And then we can observe this in our UI. And one thing I just want to point out as well, there's going to be a lot of code on these slides, but in the top right corner, there's a QR code. It's on every slide. You can get all the slides if you scan this as well. So yeah. So why use Molecule, right? Well, as a wise ogre once said, ogres have layers, and apps, in theory, should also have layers, right? Like, most modern Android developers probably agree that we're going to have layers for our application. And if we read Google's documentation, usually it's going to look something like this. They're going to suggest 3 layers, a UI layer, an optional domain layer, and a data layer. But this is a little bit of a simplification of what we actually do in most production apps, right? Like, normally it looks a bit more like this. You have a UI box where your views actually sit, like your activities, your fragments, your composables, and you have this presentation block where you have a presenter or a view model, usually. I put the domain as semi-optional because I also don't really agree with this idea from Google's recommendations, but that's not a topic for this talk. Maybe there'll be another one. So, Compose is amazing, right? Here's our same counter app running, but if we're not careful with Compose, it can really lead to us blurring the layers of what we want to do between the UI and the presentation. So if I show you that counter code again, this is pretty much the same code, but now it's like a more traditional composable that you're used to. It emits some UI. We have a text, we have the count state, and we have the launched effect that increases it. But the thing is about this logic, we're kind of mixing layers, right? Like, we have some presentation logic, which is setting the initial state and defining that every second we're going to increase the count, and we also have our UI all in the same place. Using Molecule, we can separate these two things into 2 different layers while still using Compose. So now we just have a very simple composable, just text, basically. We probably don't even really need a composable for this. We could just use text. We have our presentation logic of getting our state from a view model or whatever type of presenter you want to use. And in our presentation layer, we can have the same molecule-style composable I showed before that returns the int, and we can create our state using the launch molecule method. This is probably a bit of a better example to identify what I'm trying to use, right? Like, if you've ever reviewed a PR of some Compose code, you might have seen something like this, or maybe this is a pretty blatant example, but we're writing some Compose code to show a user profile, right? Like the user's name and their balance of their account. We have these 2 observables that are coming from a database, but we're defining this at the same layer as our UI, like where do we actually get the data for our UI. We're also defining what the start values are, again, because Compose has this weird mechanism where if you want to collect a flow, you have to define what the initial value is in your UI layer. And then we're saying we have a business logic of if the user is null, then show the loading text, otherwise show the profile UI. So the problem with code like this is there's no real way to test one part of it without testing the whole thing, right? Like, if I want to test that when the user is null, we get loading, then I have to test both getting the data from the database or wherever you're getting it from, and also test the UI at the same time. We could change this, right? By using flows, we would just define our profile model at the top. So now we are sort of separating the UI from what we want to do. We have a loading state and the data state where we have the name and the balance. And we can do a combine of these 2 database transactions. We use the onStart method to define the initial value. And finally, when the data is null, we return the loading state. And then when we actually have the data, we return it in our model. But we can do the same thing with Compose, right? Like, we can just observe these 2 observables as state, again, setting the initial value. So we pass the flows in to our composable, and we observe them, and we have our business logic. And at least in my opinion, this is like a little bit easier to read. Like, the code is a bit more imperative than the flows, and we don't have to know all these other operators from the flows library. We're just using compose the same way we did in the UI. We can then create our state flow again using the molecule library. So molecule allows us to unlock the power of compose here, like in the presentation layer. And that's really great because the thing about molecule is we're still writing compose code. Like, we still have all the same stuff that we have when we write our compose normally, like remember, mutable state of, derived state of, like controlling the recompositions, etc. But most of us don't want to just write these like presenter composables, right? We want to use MVVM and MVI because we at least want to stay kind of close to what Google is recommending for us. So how does molecule fit in an MVVM or MVI world? And just as a quick like survey again, like, does anyone use MVI in their app at work? Okay. Is there anyone who's like, I don't really know what MVI is? Because definitely a year ago, this is how I felt a little bit. Nobody's going to put their hand up, but that's okay. So MVI is a lot like pizza. If you speak to different people, they're going to give you a different recipe, right? Like, some people like thin base, some people like thick base, some people like pineapple, like me. Some people think that's like a sin. But there's really three things that make MVI different from MVVM. In MVVM, you can have many states if you want to, although you don't have to. In MVI, there's strictly one state for your whole screen. And secondly, in MVI, there's one stream of inputs, so a single place where all of your user inputs are coming into your view model. Optionally, you can have some reducer mechanism. By reducing, we just mean like this process of turning the result into your state. Like, if you want, you can separate this from the view model, and this should promote greater testability, but this is not really an architecture talk. I just really love architecture, so I'm going to squeeze the slides in. So if you go to the molecule library, you're going to find in the sample package a view model that looks kind of like this. I've changed it a little bit because this is how I like to do things, but it's mostly the same. This is a very MVI-style view model. So we have like an abstract-based view model where we pass in our state, our user events, like our clicks, text changing in a text field, etc., whatever the user is doing that we want to communicate to the rest of our app. And we have our navigation effects, which we're going to pass back to tell our screen to go somewhere else. We have these events, like I said, so we have a process method to give each event to the view model. And every time the user clicks something, every time the user enters some text, we're just going to call this method. It actually makes your composables pretty nice because you don't really have to pass all this long list of lambdas. You can just pass this one single lambda and then define your UI events as a sealed class. And then we have the state. So we have an abstract function where we're defining the state, and that's the composable. And this is what our view models are going to implement. And then in the base view model, we're just going to transform whatever comes from this composable into our actual state that the view will consume. So all good talks come with an app, right? And this is a pretty straightforward app that most of you will probably have created before for some kind of interview. It's a chess player app. We load a list of chess players. There's a details screen. But the really important and interesting part of this is that on this screen, we have these two different components. And the data from these components is coming from two different endpoints of an API. So they load at different times. We want to update the screen basically twice every time this screen opens. First, we have an initial loading state, then we're probably going to show one of the two components, and then finally we're going to show the second component at some point. If we were going to write this in like without molecule, right? Like, this is probably a more traditional view model that you're all kind of used to. We have our state, and we pass in an initial state into the constructor. And then we have a set state method that our view model is going to call whenever we want to change this. So how would the list screen look if we were just writing non-molecule MVVM style code? Well, we have this init method where we're going to load the code with our use case on the background thread. We're going to catch any errors, and we're going to update the state in our let branch here. And yeah, it's all pretty simple, right? Like, there's nothing super sexy about this code. But if we wanted to do the same thing in Molecule, well, we can separate this logic into this composable. We wrap it in this presenter class just so that we can unlock the power of dependency injection and still get our use case, but like separate from the view model. And yeah, we return our state, a list of string, and we set the initial value inside the compose. We launch an effect to get the data with our use case and log any errors, and then we return the players when it updates. In our view model, we just inject that same presenter we just saw into the constructor. And now, like our view model, as you can see, is always just going to be this one method. So we take our events and we collect them. So here we just have a continue button basically to get to the next screen and a back button. So we collect our inputs and we have a when block to make sure everything is covered. We navigate to the next screen. And then to actually produce our state, we just defer this to the presenter, basically. And yeah, as you can see on the next slide, that same state abstract fun that we just implemented, that's being transformed into our state flow in the base view model, and our view is going to consume it. It gets a little more interesting on the details screen. So we want to collect two different pieces of data, right? We want to get the player information for the first box and the player ratings to see what's our FIDE rating, what's our bullet rating, etc. We do a combine. Most of you have probably seen some code like this. And yeah, it's all not that complicated, right? We have these two flow builders down at the bottom, which I'm going to show you in a minute. And we get our flows of different states. So on this screen, you can see we're emitting a loading for the player information. Then we're just getting the data, and we're emitting a new state where we've created the new state. If we want to do the same thing with the pattern we saw before of Molecule, again, we separate these flow builders out into our composables in these presenters. So we're passing in the use case and our mapper for the time ago. That's just like turning the timestamp for when you joined chess.com into the 5 years ago. We receive the data in the composable, and as you can see, we're returning a player information state from this composable rather than emitting any UI. We set the initial value of null, and then we launch an effect to get the data, and we transform it into the same state that we had before. Same thing for the player stats. We're injecting our use case, we're getting the data and setting the initial values. Here we have a loading to show that we're loading the player ratings, because this can load separately from the player information. We're launching our effect, and now we're going to transform this into a state. But it gets fun in the view model, right? Because I showed you the code for the non-molecule view model a second ago, and I couldn't even fit it all onto one slide. Like, I had to put this on 2 slides. But with Molecule, once I get there, our view model is still just like one very, very short method. We're collecting our events. Well, we're passing in the same presenters that I showed you. We're collecting our events and dealing with the navigation events. And then we just combine, in the same way, our two composables to create our state. And anytime one of those composables in the presenters has a new value, well, the whole thing is just going to update through the power of recomposition, right? And at least in my opinion, again, like, this is a lot more readable than the collect version, but it might not immediately convince you, right? I mean, why do we need to do this at all? Well, imagine we want to add a new feature on this screen. So every time we click one of these components, we just want to change the color to a random color. We now have to inject this other parameter into our constructor, a random color code factory, add 2 more public methods, this is the non-molecule version, and update our state. It's a lot of real estate in the view model already for just a very simple feature. And with Molecule, we don't really have to do this. Like, the only difference here that was changed in our view model itself is we've got an extra event that's coming in. We're returning unit in the else block. And we're passing these events through to our presenters. In our presenter, we set the initial background color to the initial value, and then whenever the user clicks it, we call our factory and we create a new color. The whole thing updates because of the power of compose. And yeah, why do we really need to do this, right? Like, how bad is it that our view model is just going to grow? Well, how complex can apps really get? This is the payment screen from the Trainline app, and just remember that like this is without any A/B tests enabled. Like, there's like at least 20 features you can't see here that are hidden. There's a lot of different components, a lot of different data. Our screens just get complex. Like, that's the part of view models that we don't really talk about. They grow, and the more and more stuff you put in them, the harder it gets to test, the harder it gets to maintain. And for a new developer coming to this screen, I'm sure you can imagine how difficult it is to like read what's going on and try to figure out how to add their little banner that product has asked for. So you might be thinking, well, we don't really need Molecule to do this, right? Like, we can create the same thing using flows, and that's true. You can create the same player stats presenter, but instead of returning using a composable, we can just return a flow of values. We have a flow builder, we emit our loading state, and we create the state. But the thing is, here we use combine to combine the values of these two presenters. And combine is great. It provides us a really clean API, right, to pass in two flows and then get two values in this transformation at the bottom to create our state. But it doesn't really scale so well. Like, up to about 5 inputs, you can still use the same API. But as soon as you get to 6, well, now we don't really have this clean API, and we just get this array of any. We start having to do index access to get our parameters. We have to cast everything. And if you can imagine that here, none of the states are interacting, but if you actually have to start putting logic into this block where we create the player details state, it can get very hard to read, it's very hard to follow, and it's not as imperative as what we saw with Molecule. Another downside of using flows in our view model is that if you're not careful and the logic gets more complex, you can start writing code like this. And if you close your eyes and imagine, this could easily just be Rx Java, right? Like, we're just chaining a bunch of things. We're using filter, map, flat map, concat on each, catch, collect. Like, eventually, I've definitely seen some code in the Trainline app that looks like this. I don't know if you have code in your apps that looks like this. It's just not, Flows is great. It's better than Rx, but it's still not like the most ideal solution. And the problems that Molecule is solving for us is really this idea of like reducing the logic in our view model, separating it out into these composables, and giving us a much cleaner API to manipulate the state. As you can see here, another thing we can do with Compose is we can use the power of Compose, right? Like, we all at this point are familiar with the idea of recomposition. Well, imagine I had like a search field on this screen and I want to search through the players. Well, I can just create this search term at the start with our mutable state, and the only thing that really updates is this player matches presenter that I've added. So whenever we change the search term, we don't have to reevaluate the player information and the player stats. It's just the code that actually changes that we need to reevaluate because of recomposition, right? The input to this composable is changing. Finally, like, one common requirement that we often have in our apps is to have a composable or a piece of UI which is visible on many screens. So here I have this player component. You can randomize the player, and I have 3 different screens where I'm displaying it. Compose gives us a really, really nice way of writing the UI in a very reusable way, right? Like, this is just one composable. It takes a model and a lambda, and it's all very simple to copy it to another screen. But the logic of actually handling the state behind the scenes, not so easy to like make this in a nice reusable way. So here is the logic for creating this state and getting the data. And you can see at the top, this is screen 1 view model. Screen 2 view model has the exact same logic, pretty much copy and pasted. And screen 3 as well. Like, it's not so easy to reuse that presentation logic when we're using just pure view models. But with Molecule, I can again create this presenter pattern and pass in all the data, create my states. And in my view models, the logic that I'm copying between different screens is way reduced, right? Like, all of the presentation logic is isolated to this one presenter, this one composable method. And it's not that hard for me to just pull this into different screens. So I'll show you again. Screen 2 is the same thing. Screen 3. There's probably an even nicer way to write this code, but I'll admit it was 2 a.m. when I was building this, and yeah, we do what we can. So how do we test our molecule code? Well, the thing with Compose is that it doesn't really give us many tools for like testing the values that our composables return if we choose to return composables. They're mainly built for testing UI, but because we're transforming all of our logic into flows, we can just use Turbine or whatever method you have for testing flows, and it's all pretty simple. If you don't want to use state flows, you can also create just normal flows with molecule using the molecule flow method instead. And you might be wondering, why do I have a slide about a fridge? Well, my flatmate recently took up F45. I don't know if anyone knows what this is. It's functional training for 45 minutes. And this is roughly what our fridge looks like now. She's eating a lot of protein. And the thing about protein is it's a supplement. It allows our cells, our muscles to grow. Molecule is a little bit similar to this. It allows our architectures to scale in a very nice way. And this is the best analogy I could make for why you should use it. So, to recap, Molecule is a library for using Compose for non-UI purposes. It allows us to write Compose for presentation logic, not UI logic. It's fun. Like, I don't know if the talk really like emphasized this, but the biggest difference I would say between using flows or RX or whatever you're normally doing to using Molecule is like, when I wrote this like little toy app, it was just fun. Like, using Compose is fun. I'm sure you've all experienced this. And if you can use Molecule, you can use Compose not just for your UI, but also for your presentation logic. And it makes writing Android apps actually fun again. Yeah, it allows us to scale our view models much better. We can combine multiple streams of data in a scalable way. And it's great for decoupling logic from our view model and sort of reducing the scalability issue that hopefully some of you have experienced. Well, hopefully not, but here's a way to fix it. Yeah. Thanks for listening, and yeah, if you have any questions, catch me at the end.